Okay. Chapter 10 deals with conic sections. Okay. We'll also get into a little bit of polar equations later on, but for now we're going to start off a little simple just to be able to get some of the terminology you're going to need later down. Okay. So for section 1, we're just primarily dealing with lines and some of the properties thereof. The main idea we're going to be dealing with is what's called inclination. Now, the inclination is the angle formed by the line with the horizontal, or with the x-axis. Okay. So when they're asking about inclination, that's going to be, well, if it's horizontal, it's just 0. Anything else, it's just going to be the angle formed going up. Now, for this then, we're going to use the fact that we've used the formula before, but if you have the slope of the line and you need to find that angle, all you have to do is take the inverse tangent of the slope. The inclination is theta in this case, so tangent of theta is m. That means the inclination theta is equal to the inverse tangent of m. So if I have something like this and I want to find the inclination, well, what would I need to do? Well, what do I need to do first?
Find the slope.
Find the slope. What do I do to find the slope here? Yeah, I'd move the 3y over to start. So I have the square root of 3x plus 3 is equal to 3y. Then what? Divide by 3. So that y is equal to the square root of 3 over 3x plus 1. So the slope is square root of 3 over 3. From there, what do I do? Inverse tangent. Theta is going to be equal to the inverse tangent of that. So without the calculator, think back to unit circle stuff. Where on the unit circle are you going to have square root of 3 over 3 for tangent? Pi over 6 at 30 degrees. It's going to happen when the denominator is larger than numerator. In other words, when cosine is bigger than sine. So it's going to be pi over 6, or what in degrees? 30 degrees. Either one of those. Okay. Go ahead and find this one. What do you get for a slope?
5.
So what do you get for the inclination? 78.69 degrees. What would that be in radians? What would you get in radians? Give me like 3 decimals. 1.373. So either one of those. Okay. So that's the angle for one line. But if you're talking about 2 lines, the formula is a little more complex. For finding the angle between 2 lines, you're going to take the difference of those 2 slopes divided by 1 plus the product of the 2 slopes, and then absolute value the whole thing. Give you a second to write that one down. Now the nice thing is, because of the absolute value bars, it's not going to matter what order you subtract them in. Okay? So I typically do whatever's more convenient. Now, if I want to find the angle between these 2 lines, Well, what do I have to do first? Get the y from one side in order to find the slope. So here I'm going to have y equals negative 2x plus 4, give me a slope of down here. X minus 2, give me a slope of 1. Okay, so then I'm going to take tangent of the angle is going to be equal to that absolute value of the difference, so 1 minus negative 2, over 1 plus the product. So what do I end up with on top? On the bottom? Negative 1. So it's just going to be 3. Because you get the absolute value of negative 3, which is just 3. Then what? Inverse tangent again. Theta is going to be equal to your inverse tangent of 3. Just give me degrees for this. What do you end up with? 71.57 degrees. Now, that's one of the angles between the two lines. How would I find the other one? Subtract from 180. Yeah. Because if I draw both of these, y equals negative 2 plus 4. 1, 2, 3, 4. Down 2 over 1. So that's going to go about right there. Y-intercept of negative 2. Going to go up 2 over 1. So I end up with these two lines. Where's the 71 degrees at? Compared to the point of intersection, where's it at? Yeah. 71.57 is here and here. The other ones I would just subtract from 180. So typically when you're just doing two lines, you just need one of them, usually the one that's less than 90, the acute angle. You don't need both, but visually I want you to understand where they're coming from. Okay? The distance between a point and a line. This is probably the most useful aspect, or the one that comes up the most often out of this section. Finding the distance between a line and a point, the idea is that distance will always be on the perpendicular. Okay, if you draw a line, it'll always be perpendicular to the other line. So what I can do for that is this formula. The distance between the point and the line is going to be found by taking the line so it's equal to 0, plugging in the coefficients from that line as well as the point, adding them up, absolute value, divided by the square root of a squared plus b squared, the coefficients in the x, coefficients in the y. Fairly complex formula. But the nice thing is the bottom kind of looks like the Pythagorean theorem. The top's just kind of your general form for a line, standard form for a line, I should say, if you move everything to one side. And then it's just absolute value. Okay? Give me a second to finish writing that one down. Those that are scribbling furiously. Okay, so if I look at this problem, I'm going to fill in these numbers. So my distance is going to be equal to the absolute value. Well, what's your A value? 4 times your x plus times. Technically, it'd then be plus 0. You don't have to have that there, but just realize it is. Over the square root of 4 squared plus 3 squared. So on top, what am I going to get?
6.
On the bottom? That'll be 5 because that's the square root of 25. So you're going to get 6/5. So that's the distance between those. And if you look at the visual on it, the point 02, if it's right there, this is a line going through the origin with a slope of negative 4/3. So if I go down 4, over 3. Should have made this to a smaller scale. Up 4, left 3. So about here. What that's saying is if I go straight shot, perpendicular here, that thing should be a little bit more than 1. Now visually it's not quite to scale, but does it look like that's reasonable? Yeah. Okay. So, one more. And this is where I see it get used quite often. Consider a triangle. You're given 3 vertices for that triangle, 0, 0, 1, 5, and 3, 1. I want to ultimately find the area of this triangle. To do this, I need the height. Well, the height is any altitude from any vertex to the opposite line, the opposite base, right? So it sometimes helps to draw this thing to be able to see it. 0, 0, 3, 1, 1, 5. So there's my triangle. I want to find the area of that. Okay. If it's a right triangle, that's easy. This one's not. How would I find the altitude from B to C? Or from B to AC, I should say. What do I need first? Yeah, the equation of the line from A to C. So however you need to do that to get the line from here to here. The nice thing is, what's your y-intercept?
0.
So 0 for that. What's your slope?
1/3.
Careful. Oh, it is 1/3. Yeah. Forgot, I was going to step ahead of myself here. Technically, it'd be plus 0 there, right? Now, I need to do something with this next, though. Which is what? Put it in standard form, sort of. I need to get everything on one side. So what would you want to move? The y over. That gives me 0 is equal to 1/3 x plus y, or minus y, plus the 0. I'm just going to leave the 0 off. Now, I actually want to do one more thing with it. If I leave it this way, it'll work, but that means I'm going to have to be using 1/3 the whole time. Okay? The fractions get annoying when you're trying to deal with them, so multiply everything by 3. Yep. So that's going to give me 0 equals 1x minus 3y. Okay, that's just going to be nicer when I try to deal with the equation. So then if I want the distance, I'm just going to plug those in. Absolute value of your coefficients times your point. Now what's going to go in there for x and y? 0, 0? 1, 5. That point B, the vertex. And then plus 0, but I don't care about it. Divided by the square root of what?
1 squared plus 2 squared.
1 squared plus, technically it's negative 3 squared. It's going to go away the negative sign anyway, but it is there. So what do I end up with on top? Oh yeah, and this should be minus 3 up here. This is simple all over the place.
Well, 14 on top.
14 on top. What do you get in the denominator?
Minus 10.
Square root of 10. So this is actually the distance, however many units this is. Now normally I should actually rationalize the denominator and all that, but because I'm going to use this for something else, I'm just going to leave it the way it is. Now, what else do I need to find? Area. What's the formula for area for a triangle?
Height times.
Yeah, 1/2 base times height. I know the height is what?
14 over.
14 over the square root of 10. How do I find the base?
Distance.
Yeah, the regular distance formula for between 2 points. That distance formula is going to be between A and C. Well, the nice thing here is because you're going through the origin, you have 3 minus 0 squared and 1 minus nothing squared. So it's actually just going to be what?
The square root of 10.
square root of 10. If it's going through the origin, the nice thing is your denominator up here hands it to you. Okay? So from there, plug them in. Your area is equal to 1/2. Length of the base is square root of 10. Length of the height, 14 over the square root of 10. Going to give you a total of 7. 7 what?
Units, square units.
Square units. That's it for section 1. Questions? Okay. Rest of the time is yours.